Consensus. Rubix is built on proof of harvest consensus. A minimum of 21 validators are picked up from a global set of nodes. The logic is highly scalable in horizontal and vertical directions, whereas Algorand and Solana are built on pure proof of stake and proof of stake supported by proof of harvest respectively. In proof of stake, voting nodes are randomly selected, that voting is based on staking with the quorum. Database at Rubix transactions are validated independent of each other, leading to lower latency and higher scalability. All data including metadata is stored securely by the transacting nodes, but committed to the IPFS distributed file system. On the other hand, at Algorand and Solana, all global transactions are pooled into blocks to form a single ledger that is synced across all global nodes. Decentralization is high at Rubix as every node is a full node. Validators are chosen in such a way that their computing resources or stakes don't determine the chances of being the validator or earn new tokens. Whereas it is low for Algorand and Solana, this concentration also results in security risks. Security consensus is high at Rubix as validators are selected from a large global set of validators. Validators have zero economic incentive to collude. Any collusion attempt will be globally visible, leading to forfeiture of all economic value. Transaction time at Rubix full cycle including DB updates ranges from 18 to 45 seconds. A maximum of 51 million transactions can occur in parallel due to the asynchronous nature. Transaction time at Algorand is around 1 minute, which will increase as the size increases, whereas at Solana the block times are much faster than other blockchain, that is, Algorand, due to the use of VDF technology. Transaction fee. Algorand and Solana both come with low transaction fees, while the Rubix transaction fee is almost zero. Data availability and reliability. Rubix, Algorand and Solana, all three have high data availability and reliability. On-chain scaling is high at Rubix, no data storage constraints, hence no need for Layer 2. On the other hand, for Algorand and Solana, given the data storage constraints, it is not possible to scale data-wise without compromising on decentralization. Data confidentiality. At Rubix, all user data is encrypted before submitting for consensus. Validators perform consensus without needing to see underlying user metadata or PIP, whereas at Algorand and Solana it's users' responsibility to implement confidentiality layers to prevent validators from seeing the confidential data.